Hey folks, welcome, 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 welcome. We are here. I'm Ernie Roberts. It's Mathline time. We are excited to be here with you. We are glad you've tuned in. And again, Ernie Roberts for your show this afternoon. I'm your host for Mathline this round. As you well know, it's ratio week. Well, maybe you didn't know that. But we do have some ratio stuff going on. But before we get to that ratio business, we want to thank some young ladies from Bearden High School Key Club here to operate phones for us today. So you guys can call and talk to them. They'll get you there. There is Rhea, Sarah, and Omi. All right, all three of them. Thank you. They've been here before, so they're pretty good at this. They're experts. But you know what? They're giving of their time. Community service hours here. They want to hear from you. Okay, that number, by the way, you want to call to talk to them, and then you'll be talking to me, is 844-686-2378. Once again, that's 844-686-2378. What are we going to talk about? Math problems, of course. Give us those math problems, math questions, and we will rock and roll with it. Now, I mentioned ratios. Let's see what today's problem of the day holds for us. A board measuring 96 inches in length is cut into 3 pieces with a ratio of 1, 2, and 3. Wow. This isn't just find the lengths. It says find the difference in the longest and the shortest length. All right. So here's what we've got going here. Situation, let's see if we can get a picture of it here. We have a board, and it's a big orange, but we're in Tennessee, right? Well, those of you in Kentucky, I'll get you a blue board the next time, all right? And North Carolina, I think you all like red and stuff too. But anyway, I digress a little bit there. But for those of you watching us, yes, that is basically a board here measuring, we'll say 96 inches, and it's cut into 3 pieces with ratios of 1 to 2 to 3. That's an extended ratio going on there, all right? 3 parts to it. And in this case, we're going to find the difference in the longest and the shortest lengths once we figure out what each of those are. I would assume be the good thing. So let's see if we can mark this thing off a little bit here. I don't know if it's going to be happy. Let's see, George, I am going to go with about here for 1. Got it there. We'll see how good I'm doing. I don't know. I think I did wrong, folks. Sorry. We'll do another one that's a little bit longer. Now, well, let's see. Hold on a minute. Let's see if I've got another copy of this one here. I don't know that I do. We're just gonna play. All right. So we'll extend it. I can extend. I can do that. Some of you are already feeling sorry for me. Give me a call out here. All right, and we'll get this thing going. There we'll call that, and then we're going to extend this one out right over to my picture. All right, even longer. I just got a little carried away on that first board. So let's cut it right there, and we'll say we got a nice board here, okay? And so we're going to say this is our 1, this is our 2, and we're going to go ahead and color that all the way in there so you know that's our 3rd piece. And this one will probably be twice as long, and this one should be 3 times as long as the first one, but you get the idea. So let's see where we're going to go with this problem now that we've started off. We have a ratio of 1 to 2 to 3. And it all adds up to a grand total of 96 inches there, all right? So that's what we're saying. Now, no, we're not saying it's 1 inch, 2 inch, and 3 inches. No, we're saying it's in a 1 to 2 to 3 ratio. So we're going to break them up. And you say, well, Ernie, how are we going to figure that out? And the easiest way I know is that we need to multiply that 1 by something. We need to multiply that 2 by something, the same thing, by the way, and we need to multiply that 3 by something. And then what we're going to do, we're going to go up here and we're going to say if we take, let's call it x for 1x, we'll say this one is 2x, and this little guy we'll say is 3x. If you put them all together, see how it is figuratively, how it looks like a picture? We're going to add these together. So we're going to say x plus 2x plus 3x equals 96. And we're going to tally them. I see 6x going on here equaling 96. Now, big question we got on our mind is what's x? X is equal to 16. So this is good news. So we got a 16 here for 1 times x. Now keep in mind our lengths, that is actually one of the lengths. That's 16. So let's double it, get to the next one. How about it? 32. By the way, these are all inches. And then how about the next one? We'll triple that. 3 times 16 looks like 48. In my mind, I'm already checking, and we do get 96 back out of that. That's good. We did that right. And the question, has it been answered? Not yet. We're close, getting real close to it. So we're going to pick up the difference between the longest and shortest lengths. So here we go. Over here to the side, I've got room right here. We'll take 48, subtract our 16, and how about it? I'm seeing 32. So congratulations, those of you on Facebook. I believe Mark and Margie got onto it. And we have some other people who were liking yesterday. We forgot to give credit to Sharon and Vicki and David yesterday for chiming in on the problem of the day yesterday. But thank you all for tuning in, working with us on this. And that was the correct answer, 32 inches. And you know, you can always take care of just looking in advance on Facebook. We'll post it a little bit after the show tonight around 7:30 or so on Eastern Time. Speaking of on Eastern Time or Central Time, I don't know which our next caller is from, but we've got a caller waiting in the wings. So welcome to Mathline. Who am I talking with this afternoon?
Alyssa.
Alyssa, good to have you back. How are you doing today?
Good.
And for those who may just be tuning in now for the first time with us, where are you calling from? What city or county are you in?
It's a decimal.
It's a decimal. What about where you live?
Oh.
Yeah. Okay. I'm sorry. That came out kind of interesting because I said a decimal, and I thought, okay, we have a new town named Decimal. I'm great. I'm all for that. But you got a decimal problem for me today, I bet, right?
Yes.
Okay. Let's hear what you got for me, all right? We're glad to hear from you. I am.
It's 2.6
Okay.
times 0.8
2.6. And what else have we got there?
times 0.8.
Times. Okay, so we're going to take 0 and 8/10, right?
Yes.
And we're just multiplying. Is that all we got to worry about?
Yeah.
Okay. All right. Well, let's take a look at this thing. And I'm gonna do it in the vertical fashion. I like doing that. And this time you're going to keep me honest, right? And I'm going to lose the 0 for right now because it's not going to change our effect, just as long as we keep that decimal point. See where I got it? I think you're all in a little bit of delay from when we get talked in here, all right?
Okay.
You good? Are we good?
Yeah.
That's what we're wanting. Everything's good.
Yeah.
All right, so I remember you're good in your multiplication facts. You know them pretty well. So start me off here. What's 6 times 8 going to do for me?
No.
Ooh. How about 8?
48.
I was going to say, it's also 8 times 6, isn't it? So we'll put a 48. I'm going to put the 8 there, and I am going to put the 4 up there at the top, and you're going to remind me, Ernie, to add that 4 in, right? At the end here. You're good. You're a good assistant for me here. So 2 times 8, you got that one, I bet.
16.
16. Very good. Now, what are we going to do, Alyssa? We're going to do what with that 4?
Add the 4 and it would be 20.
Yay. Thank you. Now, you're talking, I know the decimals have been the concern because we got to figure out, is that decimal, where's it going to go in the final answer? We got the 208 right. Everybody's agreeing with me out there. I see all of our audience and viewers nodding and saying, Alyssa, you did great. You kept Ernie on track on this one. So what we're going to do is we're going to count how many places to the right have we got. Now, sometimes people want to line them up, but that's only an addition and subtraction, isn't it? So we got to count. So we're going to pick it in from here to here, and that basically jumped from the 8 to the 0, and now to the 0 between the 2 and the 0. And I'm going for 2.08. Does that sound good to you?
Yeah.
Did we do it right?
Yeah.
Yay.
Finally. Again.
And you're good. Thank you for helping us out there and calling us in, and keep doing that, all right? We love hearing from you. Thank you, Alyssa. All right, bye-bye.
Bye.
I tell you, Wednesdays, and we got fun with the Beard and Key Club here today. They're taking calls, and I understand we got someone also in the wings waiting. So to my next caller, welcome to Mathline this afternoon. Who am I talking with? Are they there? Welcome to Mathline. Who am I talking with? Maybe we lost them. Okay, all right. We'll try that again. All right, in just a second. So, how about a little fraction moment? We just had decimals. Let's do a quick fraction moment here. and see what is going on in this real realm of the world here. It says, put the following fractions in order from least to greatest. Now, yesterday afternoon, and I want to again thank Gary Petco for being with me Monday and Tuesday, Knox County Math Supervisor of Knox County Schools, public schools here. Great guy, and also a really, really strong thinker in the world of mathematics, process, and all those good things. But we talked about benchmark fractions yesterday, and today I've thrown quite a few in here, all right? And 1/3, we don't usually think of it quite as a benchmark fraction, but it's somewhere in there. Now, while we're doing this, by the way, the idea is give us a call, all right? And that number is 844-686-2378. We want to hear from you, all right? So please give us a call. But the idea on these, we trying to think of where are they in respect to each other when we're going to try to figure out which was the smallest and take it out to the one that's the greatest of value, all right? So when we're looking at this, we have 3/8, 1/4, 1/2, and 1/3. So let's play it out. And you know what would be nice if we could get this all in terms of the same denominator. Now I think of 1/2 being in the middle. But you know what I'm also noticing here? That 1/4, I know 1/4 is less than 1/2. It's right between 0 and 1/2. 1/3 is less than 1/2. And notice 3/8 isn't quite at 1/2. So all of these are smaller than 1/2. So I already know what the greatest is. I know it's going to be 1/2. But let's see if we can't get these things into numerical moments, because they're the 1/4 and the 3/8, I've got that. I know 1/4 and 3/8 and then 1/2. If we know our benchmark fractions. Some of us do, some of us may not. But that 1/3, where's it going to go? Maybe between 1/4 and 3/8, or maybe between 3/8 and 1/2. Let's make sure. All right, let's make sure. So what we're going to do, we're going to take each of these and we're going to get a common denominator on this one. All right, and we already know we're going to put 1/2 at the end, so that took some of the mystery out of it. All right, and by the way, with 1/2 up here at the end, what is our common denominator going to be? If we were to say goodbye to 1/3, we would have 2, 4, and 8, and 8 is the number that all three of those will divide evenly into. It's very nice because 2 divides into 8 evenly, 4 divides into 8 evenly. That would be great. Unfortunately, 3 doesn't fly. 3 does not work it very well. So let's do this. Let's multiply 8 and 3. Why not? It gives us 24, and that will give us a number that all of these will go into. So we'll pick up 24 on each of these, and then we'll get them in order. Now, I'm going to go ahead and leave 1/2 where it is, all right, so we don't get confused. And someone who just tunes in says, why did he just say 1/3 is 1/2? No, it's not that way. We know it's going to be the biggest, okay? We know that much. And I'm really ready to say 1/4 is going to be the smallest, the least. But let's put our numbers on here. So if we have 8ths, that means we multiplied 3/8 times what? To get to a 24 and then what we had to multiply by 3, which means we're going to put 3 over 3. So 9/24 is what we get here. A lot of times we think of it, divide 8 into 24, goes 3 times. 3 times the 3 gives us 9. Easy shortcut way. Now what about our next one here? Easy. We got a 1 in the numerator, which helps. So 4 divides into 24. It's going to go 6 times. 6 times 1 gives you 6. So already I did say 1/4 was going to be less than 3/8. Everybody's agreeing? Good. We know this one is going to give us half of that, so it's 12 out of 24. The big question is, what are we going to have here? So we are going to divide what? 3 into 24. It's going to go 8 times. 8 times 1 gives us 8 over 24. Now it's just a matter of not worrying about the 24s. They're all the same, right? So let's go to the top. This is definitely the smallest, okay? Because 6 is less than 8. 6 is less than 9. 6 is less than 12. So we'll start and pull the 1/4, which goes with that, right there. So 1/4 is the least. Our next one, how about it? I'm seeing 8. 8 out of 24 there. So 1/3 pops up next. And then we're working our way up to 9/24, which is pretty close there, folks. But still a little bit more, So there's your 3/8 moment. And, wow, 1/2. So there's your ordering from least to greatest, all right? And again, common denominators, get them all into some sort of common comparison form. And some of you said, well, Ernie, could you just make decimals out of them? Yes, you could. You could have done that too. And with a calculator, it was pretty easy to do that. But you could have made decimals and compared them in their size, and that would allow you to order also. So a couple of ways you could work through that problem. Benchmark fractions, of course, half and a fourth. And I like to think of those eighths as benchmark fractions because when we work at rulers, that's what we got. We got all those different markings on the ruler in halves, fourths, and eighths. So speaking of all those great things, let's get some calls going, all right? Give us a call. Lisa has led the way today, giving all of you some incentive to call. Let's go ahead and get everybody else calling, all right? That number is 844-686-2378. We got these Bearden High School Key Club operator ladies here, and let's make them have some fun and get some business going, all right? In the meantime, how about it? Hey, Mathline, we got one of those waiting? Maybe we don't? Got it. Okay. We're looking for a Hey Mathline here. I think we have one. There.
Hey Mathline, I am Reese from Maryland. What number divided by 12 would give you a quotient of 3 with a remainder of 5?
Reese, I love that smile. I love that smile at the end. We bring Reese back every year because he makes you happy. He makes you happy here. So what number divided by 12 will give a quotient, that's what happens after you divide, folks, of 3 with a remainder of 5. All right, are we ready? Figure it out? Let's go with it. Oh, someone was trying to guess, it looks like. But let's see. What number divided by 3? I'm thinking, what do we end up with? We end up with 5. And then I'm going to just play with some arithmetic. What did we do? We divided 3, nope, we divided 12, right, into some number. Went 3 times, right? And then this was what was left over. So we'll consider like a little plus to add on there. So let's go back and think just a second. If we do 3 times 12, that's 36. And that's how we would get it. We have the quotient of 3, and then we have left over. But you're saying, but Ernie, that goes 3 times. Yeah. So what do we got to do with this thing? So we're going to go back here. Let's say we're going to take x into, we're going to divide some number by 12, and then we're going to, what are we going to do here? We're going to have some thought on this just a second, aren't we? So let's work backwards. How about it? X over 12 and plus 5. So what do we get? We got 36. And if we add 5 to that, we are at 41 there, Reese, okay? Now, let's go back. Let's put that 41 in here. See if it works. 41 goes into 12. Oops. And what happened to that? We are going to get 3 with a remainder of 5. So let's divide that 12 into 41. Again, it goes 3 times. 3 times 12, 36. And we have 5 left over. So that's what we're looking for there, buddy. So it's kind of like an x over 12, and that x is 41 here, all right? And that's what we're trying to get to. As things go, we had it rocking and rolling there. And Reese, thank you for giving us that to think about, and thanks for that smile. It makes life good. I understand we have a caller waiting on the line as now, so welcome back to Mathline. Maybe it's our caller we lost earlier, so I hope that you're here. Who am I talking with?
Lucy.
Lucy, how are you doing this afternoon?
Good, how are you?
I'm doing fine, Where are you calling from?
I'm calling from Knox County.
Well, Knox County, glad to hear from you this afternoon. And Lucy, what kind of problem have you got for me here?
Okay, my problem is 25x minus 13y equals c.
So let me try again.
And then
25x what? Minus
13y
equals to?
Equals c.
C, as in the letter C. Okay.
And then solve for x.
Oh, this is one of these literal equations that we've got to get an x by itself.
Mm-hmm.
Now, you know, a lot of times they'll ask for y, and we'll get a slope-intercept form out of this. But, folks, we're going to isolate the x. Whew, we got a few steps to go on that. So things that are keeping me, Lucy, from getting x by itself, I want to ask you, what's the obvious thing that needs to move first, do you think?
The 13y.
Yeah, and we need to move the whole thing in one lump. We'll do it in one lump, because sometimes people think, well, do I just get rid of the y? No, let's go ahead and move everything, because it's basically attached by that subtract symbol. So we're going to add 13y to the left, and guess what happens? We also add it to the right. Does that make sense so far?
Yes.
We good? And I'm going to let those y's disappear because that was the whole idea. But now they're popping up on the right side. So let's see. I've got 13y plus this value of c. And over here, I've still got 25x. Now, Lucy, 25x, that means multiplication, doesn't it?
Yes.
All right, so we got 25 times x. I've got to get the x by itself. So what am I going to do with this? We're going to divide by 25, correct?
Yes.
Because I'm undoing the multiplication, so I've got to divide through. And that little property of equality says if we divide on the left side, we got to do what? Divide it on the right side. And that's not very pretty, is it? But the whole idea is if we know what y and c equals, then this makes a little bit more sense. But we haven't been given that value. But if we knew a y and we knew a c, we could work it through our little formula right here, which is right down here, and we'd come up with our x value that would go with that. So in a lot of cases, we do this, especially when we're trying to get formulas, like area formulas, trapezoid formulas, all sorts of different type things, where we try to isolate a variable. Also in physics and chemistry, there's always that time you're trying to isolate stuff. So it's basically what we call a literal equation or a formula, and we're just trying to get x by itself so we can do something to find x if we know the other two numbers. So Lucy, thanks for calling this afternoon, all right? We appreciate you. And
Okay, thank you.
oh, thank you. And we think we got the answer right on that. I think we did. Alyssa, tell us, all right? Yeah. So again, what we like to remind you is that we do have Facebook going on, and we'd like for you to like us, love us, and above all, share us, all right? We put the problems out usually about 7:30 on the night prior, and we hope to get a lot of people to look at them, get into the answering mode, and play with, like I said, it's ratio week here on Mathline, so we hope you will do that. Also, sometimes when we have ratio week, we may see some proportions, so who knows what tonight's problem of the day will hold for you, all right? But in the meantime, why don't you call us, 844-686-2378. These young ladies from Bearden have been giving their afternoon today. We've had a couple of callers, and we appreciate that. And we hope that, once again, that we can keep them coming back because they seem to attract people to give us calls, and that's good. But we do want to hear from you, ladies and gentlemen. It is 844-686-2378. Now, thinking of if we can come up with something fairly quick and easy to finish out the afternoon with here. Got about 3 minutes left. Let's see. How about one of these good old right triangle questions? And if someone should call in, we'll just save this one for another rainy day or another day when it's pretty. It's sunny like tomorrow. So, first of all, it says, find the perimeter of an isosceles right triangle. Ooh, geometry time here, my friends. With a hypotenuse of 20 meters. I hope we can get this done in the time we're being allotted here. Not a lot of time here, but let's see if we can put it together here. We'll draw an isosceles. By the way, isosceles means two sides are congruent, and a right angle means just that. We're going to get a right angle going in here. And we want to make these two sides that are making the right angle, they should be the equal lengths. And we're going to pull it out just a little bit more. Now, let's cut it right through here. We got a caller. You know what? I understand we have a caller. We are just going to let this wait till tomorrow. Let's go ahead and get to our caller, okay? And if we should not finish, just stay on the line with me, and I'll finish it off once we get through our credits and stuff, okay? Welcome to Mathline this afternoon. Who am I talking with?
My name is Sydney.
Sydney, how are you doing today?
Good, how are you?
I'm doing well. Sydney, where are you calling from?
Sweetwater, Tennessee.
Sweetwater, Tennessee. Glad to have you with us today. What kind of problem have you got for me today? We'll at least try to get it set up, and if you'll hang on the line after the show, we'll finish it off for you if we don't get it done in time, okay?
Okay, thank you.
Mm-hmm.
It's a word problem.
Okay. I like these. Go for it. Let's see what you've got.
There are 340 children at a park.
I'm sorry. Go back and start over again.
There are 340 children at a park.
Okay, got it.
2/5 of the boys is equal to 4/7 of the girls. How many girls and how many boys are there at the park?
Oh, my goodness. Okay, so 2/5 of the boys equals, what did you say, 4/7
Yeah.
of the girls?
Yeah.
Okay. First thing first, this sounds like systems, okay? I'm going to use systems. I'm going to use X and Y. Is that all right? Is that what you're kind of expecting me to do?
Yeah.
All right. So I'm going to go ahead and say, I'm going to let X equal number of boys, and this is important to assign these things, and let Y equal the number of girls. And from what it sounds to me, it says 2/5 of the boys. I'm looking at 2/5 X equaling 4/7 of Y. Does that make sense?
Yeah.
All right. And also what we're going to do is the other equation I'm going to use is X plus Y equals 340. And we will finish this one at the end of the show. All right. I'll talk it to you, and we'll also put it back on the show tomorrow for our viewers. Hey, folks, thanks for tuning in today. Thanks for calls that we got. Thank you, Bearden High School, and we will see you again next time.